Welcome back, class. We are now in section 1.8, which is about kind of like an introduction to graphing. Okay, so it's about the coordinate plane. So this should be hopefully a fast section. Um, we know like 1D, 2D, 3D. What do we mean by that, right? I hope we all kind of know what that means, right? 1D is a line, right? And that's like the number line that we did our like sign chart thing with last section, right? It's what you see at like the start of all classrooms in elementary school, right? It's the number line. That's 1D, right? And then 2D, right? It's the plane. And that's what we're dealing with here. Okay, so to make 2D, or also known as R2, right? R. To make that, we take an x-axis, a number line, and we cross it with the y-axis at a 90-degree angle, okay? And so we're going to talk about this right here, okay? So we're only going to go to 2D. We're not going to go to 3D. That requires some fancy math, okay? So these, okay, these are called the axis. This is the x-axis. This one is the y-axis. These are called quadrants because there's 4 of them. Okay, and we number them counterclockwise. So this is the first quadrant. This is the second quadrant, the third quadrant, and the fourth quadrant. Okay. Right here, where the axes cross, okay, that's the origin. Right? And so this is the 2D graph, okay? We're gonna familiarize ourselves with stuff, okay? So points, right? Points on a number line were just numbers, right? 1 and 2. Points on a 2D graph, okay, are a little more complicated. They are what we like to call an ordered pair, okay? So here is a point. It always goes x, y, okay? So a point is an ordered pair, okay, where x is the x coordinate and that goes first, and y is the y coordinate and that goes second. All right, so if I had the point here, okay, 4, 2, so 1, 2, 3, 4, so 4 is gonna go there, and then 1, 2, and a 2 goes there. All right, so this is the point 4, 2 because of this. All right, we can also, if we want, have the point, right, like 1, 1, or -1, -2. Okay, so you should be somewhat comfortable with just putting points on a graph, okay? Not too difficult. And now I'm going to introduce some formulas, okay? So these are favorite questions to put on final exams, okay? Here we have the distance and midpoint formulas. Okay, so distance, I already kind of introduced this. So we have distance between 2 points, P1, P2, and this is in 2D, okay, is square root x2 minus x1 squared plus y2 minus y1 squared, okay? And a big deal that I want to mention is that you notice this is a number, okay? Distance is like 5, like meters, or 6 inches or whatever, right? The midpoint formula Okay, so m of P1, P2 is going to be x1 plus x2 over 2, comma, y1 plus y2 over 2. Notice that the midpoint formula gets you a point. Okay, it's not a number. All right, a very common mistake people do is they just like erase these and then they just add them together at the end. I have no idea why, but that's just wrong. Okay, the midpoint is a point. This is the x coordinate. This is the y coordinate. Okay, and so let's do some quick examples with these two formulas. Okay, so first example is actually really easy because it's going to be in R2. I mean in R1 technically. Okay, so I have the point 0, 1, and 0, 4. Okay, so I want to find the distance. And right, we don't even need the distance formula really, right? I hope we can all kind of see with our eyes, right? The distance is 3. But if we want to do it like the proper way, we would do square root of 0 minus 0 squared plus 4 minus 1 squared, which gets you square root of 9, which is 3. Okay. And this is easy because it's just 1D, right? We don't have to like this is a straight line. The midpoint formula, okay, is 0 plus 0 over 2 and 4 plus 1 over 2. So the midpoint is 0 and 5 halves. Okay. All right. So in 1D, it's really easy. All right, now we have two other points. Okay, so 1, 2, and point 2 is negative 2, negative 3. Okay. So 1, 2, negative 2, negative 3. Right, you need to figure out the distance and the midpoint. It probably doesn't cross at the origin. Probably on actual graph paper, but it kind of looks like this. Okay. So distance. So now we plug it into the formula, okay, and it's actually going to be useful. So negative 2 minus 1 squared plus negative 3 minus 2 squared. So this is negative 3 squared plus negative 5 squared, which is 9 plus 25, which is 34. Okay, so the distance is square root of 34. It's frequently going to be a square root. Okay, and the midpoint is 1 minus 2 over 2 and 2 minus 3 over 2. Okay. Technically it should be like plus negative 2 if I want it to be like super plugging into the formula, but it's okay if you don't do that. But we get negative 1/2 and negative 1/2. So the midpoint is like this, which makes sense. Okay, but here's the two formulas. Okay, they're important. I would encourage you to memorize them, write them down somewhere. Okay, don't forget them. And that's it for midpoint and distance. Really, is just here's two pieces of info. Find them out. Okay. Next, I'm kind of gonna go through this part quickly because I don't really like how your book does it. Okay, so your book introduces graphing. Okay, but we're actually gonna learn to graph lines in the next section and then other things much later on. But what your book wants to teach you is kind of the backup plan. Okay. So like so to graph this, okay, One thing you could do, which is what your book is going to teach you, is you can just plug in a bunch of numbers, okay? So like -2, -1, 0, 1, 2, okay? And if you plug these in, you see that you get other numbers, right? And so these are points. You can think about them, right? The left is the x coordinate, the right is the y coordinate. And so if you plug all of those in, and then trace it, you get the graph. Okay? So this is one way to always graph, is you just plug in a bunch of points and then connect them, okay? Which is fine for lines. Lines are, lines are nice and you can do that. What I don't like is that the book then wants you to kind of graph this. Which this is more complicated. You kind of should know a better way to graph this, which we'll teach you later. But if you plug in some points, so let's go -3, -2, -1, 0, 2, 3. The more points, the more accurate your graph. That's basically how any graphing calculator actually graphs. What? Negative. Oh, I forgot 1. I lost myself. I was very confused. 1, 2, 3. -1 goes to -2, 1, 6. Okay. So if we see here, if we plug in all of these points, -3, we're gonna go here, and then we're gonna go here, and then it shoots off. So we get the parabola that we're supposed to get. Okay. So for right now, if you need to graph stuff, you could just, punch in a whole bunch of numbers. Okay. That's kind of what this section is about. Okay. So, moving on to the actual other important part of this section, okay, circles. Okay, so we need to know about circles. So, first thing is what I'm gonna call circle form. Okay, so like a circle has something called standard form, and this thing, which I'm gonna call circle form. Okay, so it will look like this: x minus h squared plus y minus k squared equals r squared, okay? And so this is circle form. R here stands for the radius, which hopefully we all know what the radius of a circle is. It's this length, okay? The length from the center to any point on the circle, okay? And then this, okay, so big deal, h and k, okay? The center of the circle is h comma k. And so notice that the sign flips, guys. So this is negative h and this is just h, okay? So there should always be a sign flip when you write down the center, okay? So let's just, have a circle, an example. So x minus 1 squared plus y plus 2 squared equals 9. Okay? So from here, hopefully, you'll be like, wait, 9 is actually 3 squared. So the radius is 3. And then the center, you look at these two, and you're like, okay, the center is 1 comma -2. Okay, because the signs flip. All right? Okay. So not that hard. Okay. Now you should be able to do a couple things with the center of a circle, okay? So let's pretend, okay, we have this kind of, it's like a word problem, but not really, okay? So we have two endpoints of a diameter of a circle. Okay, so circle, a diameter. Okay, the first point is 1/8. The second point is 5-6. Okay, obviously my circle is in the wrong spots, but whatever. 2 points, diameter. Okay, so since I drew the picture, I hope you could tell that, like, wait, if I have a diameter, then the midpoint of these two is the center, right? Because that's how a diameter works. It's two radii stuck together. So diameter. Okay. So we're going to use the midpoint formula, and this is why the midpoint formula is important. Okay, so 1 plus 5 over 2 and 8 minus 6 over 2. So this is going to get 3, 1. So the center of the circle is 3, 1. Okay. And the radius is just going to be half of this distance. Okay. So we're going to need to use the distance formula. Okay. So distance, I'm going to do 5 minus 1 squared plus -6 minus 8 squared. This is going to get you to 16 plus, this is a big number. This is definitely going to be -8 minus 6, 14 squared, 196, which that is going to be 212. Okay, so this is the distance of the diameter. So the radius is going to be square root of 212 over 2. So the equation of the circle, well, we can write it down. It's going to be x minus 3 squared plus y minus 1 squared equal to r squared. So r squared would be 212 over 4, which you could simplify that. 212 divided by 4 is 53. Okay. So ta-da! This is kind of the word problem version of just what's a circle. Okay, is they'll give you like a radius and a center or a diameter or something like that, and you'll have to use probably a distance and midpoint formula. Okay. All right. More importantly, though, this is a question I like to ask more. Okay, is I give you a circle, okay, but it's not in circle form. So here's a circle in standard form, okay? 2x minus 6y plus 6 equals 0, okay? Standard form is just, it's jumbled up. There's like no parentheses anywhere. Because now this is an interesting exercise to put it into circle form, okay? Because actually what you have to do is you're gonna have to complete the square. All right, and this is why I told you guys when I taught you complete the square that it's not gonna go away. Okay, in fact, you have to complete the square twice here. Okay, So step one, I'm going to say, is I'm going to rewrite this equation. So x squared plus 2x plus blank, okay, y squared minus 6y plus blank is equal to, and I'm just going to move the 6 over, so negative 6, okay? Now, I have to complete the square, so hopefully you're okay with completing the square, right? B is 2 here, so B is 2, B over 2 is 1, B over 2 squared is 1, so I'm going to add 1 to both sides. Okay, over here, B is negative 6, so B over 2 is negative 3, so B over 2 squared is 9. So I'm going to add 9 to both sides. Then, this, right, you completed the square, becomes this. This one, complete the square, becomes this. And this you just add. So 9 minus 6 is 3, plus 1, 4. So ta-da! Okay. And actually, it's kind of nice, okay? Because you can see that the center is negative 1, 3. And the radius, and this is a big deal, okay, big deal. The radius is 2, right? Because this is 2 squared, okay? Very common mistake that people just write 4 for the radius, okay? So make sure that's not you, okay? Make sure that you remember that it's the square root of this is the radius, okay? Or this number, because it's r squared, okay? And so that's pretty much it for this section. All right. This is study this. All right. Just to finish off though, your textbook does like to talk about symmetry, okay? Which we will talk about much later on. Okay, but symmetry, we have 3 different kinds. Okay, so we have symmetry about the x-axis. Okay, and that'll look something like this. Okay, like this. A circle is technically symmetric because, right, if you fold it in half across the x-axis, it should match perfectly. Okay, so this means, let me get some space here. This means if you replace y with negative y, nothing changes. Okay. Now the other one is very similar. Okay, so we have symmetry about the y-axis. Okay, and we already saw something that does this. The parabola, okay? Parabola, y-axis symmetric. Okay, circle, technically also y-axis symmetric. Okay, the circle is just like every kind of symmetric, okay? This, we can replace x with negative x, and nothing changes. Okay. And then the last kind of symmetry, okay, is symmetry about the origin. Okay, and this one's a little funny. Okay, so first of all, this looks like this. Okay. And technically a circle. Okay. Because if you flip it twice, if you flip it here and then flip it again, okay, then it matches. Or what a lot of books like to say is it's symmetric across the line y equals x. Okay. All right. But to figure it out, you just have to replace negative y with y and negative x with x. Okay, and nothing changes. Okay. So let's just do one or two examples here. I'm gonna have y equals x squared, okay, which we know is a parabola, hopefully. So this should be y-axis symmetric. So to check, I'm gonna plug in negative x, and right, we know that negatives inside of squares, they can just like disappear. So it's x squared. So you see when I plug in the negative x, nothing happened. So this is why it's y-axis symmetric, okay? Now, since the origin one is funny, let's do that one. X cubed plus 2x, okay? So I'm gonna replace y with negative y and x with negative x. Okay, and now I'm gonna simplify. So, right, because this is odd, I can pull out the minus sign and get this. And then this is just gonna be like a negative 2x. And then I'm gonna multiply both sides by negative 1. And look, I got back to here. Okay, so this is symmetric about the origin, okay, because when you plug in two minus signs, essentially they just cancel everything out, okay. All right, not too important. Definitely the big deal from this section would be the circle form, okay, getting stuff in circle form, and then midpoint and distance formula. But that's it for section 1.8. See you guys next class.